Now, now we're gonna basically discuss the three conditions where something can float, something can sink, something can rise. So in floating condition, I would like to tell you that the weight is always down, and if the weight and say the upthrust are exactly equal, then basically the object will just float. All right, so neither it will rise, neither it will go, and it's sort of a position where it's in equilibrium. All right, so we can say at this condition, yeah, so then I will take W as the weight and U as the upthrust, and then we're going to talk about drag as well. So let's take D as drag. Okay, drag is a force that basically opposes motion. Now, okay, so keeping that in mind, then um, the next one, when something is sinking, we should remember that sinking means that it's going down, which means weight is the biggest force. Then you got upthrust, and then you have like drag as well. Smaller as well. And the reason why drag needs to be drawn up, because the velocity will be down, so it's sinking, so drag has to oppose the speed, right? So in this one, weight is the biggest force, so weight will be equal to upthrust plus drag when it is moving at constant velocity. And the reason is that now drag will only oppose the velocity, it will never go in the same way. In case of rising, then weight is the same, which is down. The upthrust has to be the largest force, and that is the reason why, to balance this out, you will have drag, like drag will act, and because drag now acts downwards because the velocity will be up. Yes, yes, you have a question? Yeah.
In the sinking option, if both the downward force and upward force are equal, if weight is equal to upthrust and drag,
Yeah,
how is
yeah,
it going downwards?
they are equal, but the thing is that they are being balanced by the drag. All right, so it must have some speed before, so they're going at constant speed. So there are two conditions of equilibrium: either you stay at rest, or move at constant velocity, right? So it is moving at constant velocity, but in this one you should remember that why would in the first place it would sink. The only reason it would sink is when upthrust will be greater than weight will be greater than upthrust. Do you understand, Khadija?
Yeah, circle.
And similarly in this one, upthrust being the largest force, it will be like weight plus drag. Now this will be the equation, and the reason why it is this, because upthrust now will be greater than weight in the first place. That is why it started to move up, and later on, obviously, as the drag would increase, the forces would balance, and it will continue to rise at constant velocity. So that we should remember. All right. Okay, anyone who could not understand this? Aman Javeria. Ji हाँ. Again, all of this.
Sir, could you explain the last part?
Okay, what I'm saying is there would be like, if there's an object like this, right, and it has smaller weight, larger upthrust. So obviously the object will accelerate upwards. You guys agree?
Yes,
Because
sir.
the forces are unbalanced. As it accelerates, so its speed is going to increase as well. So when the speed increases, there will be a time when, although the weight is smaller and upthrust is larger, but there will be a time when it will reach a terminal velocity where drag is going to balance out the difference between weight and upthrust. Do you understand? It's just like, falling in air. When you used to fall, drag used to increase slowly until it would be equal to the weight. So what's happening here is that slowly the drag is increasing every single time, and then there is like one point where when the downward forces become equal to the upward force, that is when we say now it has reached equilibrium and now it is moving with constant velocity. Is it clear? The only thing that you guys need to focus is that in rising, drag is down because velocity is upwards, and in sinking, drag is up because velocity is down. And the main function of drag in this is to balance out the difference between weight and upthrust if there is any at a certain velocity, okay? Like that. Now, these three conditions will be like similar diagrams will be there in your exam. Like for example, here. So in this one it says a spherical object falls through water at constant speed. It says falls through water. So we are right now thinking of sinking, right? You guys agree? Now he hasn't told us what are the three forces, but obviously in water there's going to be weight. So it means all of these are weight. And then there will be upthrust, which means one of these force will be upthrust. And because it is sinking, like the velocity is down, so drag will also be up. But the question is that which diagram should be correct? All right, because it has reached a constant speed, so it means that the upward forces and the downward forces should be equal. Which diagram do you think shows that?
B.
It is B, not C, nor A, right? The reason is there is a difference, and C is close, but in this case, just whenever you're doing it, right, just try to use your ruler. So approximately these forces will be equal to this large force. All right, Ayan, do you understand? And Ahmed and Khatija, Maham, Sultanat, Wajiha.
Yes, sir.
Okay. And Javeria, okay. Umar, Yaya. Everybody understands this, right? Should I go forward then?
Yeah.
Yes.
Okay, then in this one,
Sir, did you mean the both of the upward forces should be
Yeah.
equal to the one and the
yeah, their sum should basically be should be equal to the force at the bottom. In this particular question, if it was rising, then obviously it would be flipped upwards, right? Upthrust would be biggest, and then drag and weight would be down, like that. Okay.
Yes, sir. Okay.
Alright, so this question is pretty easy. I will leave this, so it just looks hard. You just need to find the weight, and I just want to tell you that you don't even need to do anything in this question, just use little bit of your brain. Okay, and you will find the answer to this. And the answer is basically given right in the diagram, so please do it, and if you don't understand, let me know by tomorrow. Anyway, now this is the same diagram, and this can also be done. You guys can do it easy. Please try to do this, otherwise ask tomorrow. Now this one we'll do together. It says a submarine is in equilibrium in a fully submerged position. Okay, what causes submarine? Can anybody answer this?
The velocity downwards.
The velocity downwards? No, upthrust is not that. I'm sorry. What causes upthrust? Anyone?
See, there is a difference in water pressure.
There is a difference in bottom and top of water pressure. That is exactly the definition. So that is very poor, by the way. Is it clear, everyone?
My bad, sir.
Yeah.
I was confused between drag and upthrust.
Okay. So then we're going to go to the next one. So then we have this question, which obviously I will try to do. So it says which are scalar vector, acceleration is obviously vector, force is a vector, kinetic energy is scalar, momentum is a vector, power is a scalar, work is scalar. But the real question starts from here. Now it says that a floating sphere is attached by a cable to the bottom of a river. As you can see, the sphere is in equilibrium with the cable at angle of 75 degrees, assuming the force on the equilibrium due to the water flow in the horizontal direction. That's fine. The radius sphere is given, and the sphere is made of solid, and it's made from material density this, and show that the weight is this. So we can do this easily. The way you should basically look at it as that for weight we need mass times acceleration due to gravity. We have this, we don't have mass, and then if you have density, then obviously it should come out as mass over density. So to find mass, I need to multiply density with volume, and because radius of the sphere is given, so I can use the sphere formula, which by the way you guys should remember. So it's going to be 82. It is in meter, so we're going to convert this in meter as well, which is 0.23 meter, and it is 4 by 3 pi 0.23 cube. So that's the formula. So once you do that, then you just need to multiply the whole thing. Like to find the weight, you need to multiply this whole thing with 9.81. All right, what do you guys get? Can you find the answer, please? 14? 41? 41. Okay, so that's 41 Newton. Are you telling me because they have given the answer, or is it like you've calculated it? Okay. Alright, good. So then what you're going to do is you're going to go to the next question. It says the tension the cable is 290. So now the weight, which always acts downwards, it is 41 newtons, and says this cable has a tension of 290 newtons. All right, so it says determine the upthrust. Upthrust is going to be upwards like this, and you guys should understand that basically this tension is being caused by the upthrust, because upthrust is sort of pulling it up, right? So what we're going to do is we are going to make two components of this. One of those components, one component of the tension will be up, one will be right, and that is caused by this force, this is caused by this force. So this is 75, so this component is going to be, you guys should understand, angle is not next to the vector, so we're going to write 290, which is our main vector, sine of 75 degrees. All right, Laiba, do you understand now?
Yes, sir, it's clear. But I didn't
Okay.
ask anything.
You asked me once that vertical has to be sine only, and I said no. That's why I
Yeah.
always ask you this. Okay. So 290 times sine of 75 is the upward force that is acting on it. Can you please find this? What'd you get?
280.11.
280.11. Right. Okay. Which basically means that 280.11. Well, that should be too right. Wait a second. That is the force that basically the tension is pulling it down, and then it should oppose that. So, yeah. Don't think that is correct. Wait a second, please. Okay, so the reason is that now I just basically made one small error. It's not an error, but you need to add 41 into it. Can you please add 41 into this? And then I'm going to explain why. Yes, please. What you get?
321.11.
321.11. So it's gonna be, you can write 321 newtons or just or 320. All right, now why do we need to add this value of weight into it? So I'm just gonna make a small brief drawing, all right, to explain this. So basically your weight was down, right, and this was also pulled down by a cable, and that was 290, right? So basically I made different vectors, but I should have made, to be more exact, I should have made a vector like this and a vector like this. Because this was 75, then obviously this is going to be 75 as well. So this vector of the tension should be 290 sine of 75, and the upthrust is up, right? So because it is balanced, so these two forces are down, so I added the component of tension sine theta plus weight, and that would give me the upthrust. Do you guys understand this?
Yes, sir.
Yeah. Then it says explain the origin of upthrust acting on the sphere. Obviously it is the difference of pressures on top and bottom of sphere that is equal to where upthrust is equal to the weight of water displaced, right? So that's what in this question is. Otherwise you could write fluid as well, like that. Okay, now if you guys have any questions here, please let me know. All right, so then we're going to go forward, if you guys have copied this. Okay. So, uh, for this one, this is pretty easy. This is for your homework. Please do that. And I don't think so. There's much of it. And finally, then we are going to look at this one. This is also your homework. This is the same question that we've, just done. They're just asking for the third force. You should remember that. It's just the case of rising. So just apply the equations, you will know. Other than that, yeah, this is also your homework. This is less complicated. This is the same type of question that we have just done. Yeah. And this is also your homework. That is pretty simple. The same question that we have done. So now we're going to move towards combined density. And combined density is basically a very critical thing. For example, I'm just going to tell you what people do. So suppose there are two different materials that you mix together. One has density 1, one has density 2. Mass 1, volume 1, mass 1, volume 1. So what most of the people do is, and that is the correct method, that they basically to find the combined density, you need to add the masses together to find the total mass, and then you got to divide with the total volume. So this is the right method of doing this. But what people do is they find the density of the first material, like they say combined density. They say m1 over v1 plus m2 over v2. This gives you like density of individual, and then you add it. If you notice in these two formulas, like this is absolutely the wrong method. And if you notice in both formulas, like this whole function and that function are completely different mathematical functions, and you should never ever use this. Is it clear, everyone?
Will you give a wrong answer, sir?
Obviously, it is going to give you a wrong answer. So you will never ever use the second method. It is the wrong method. Okay? Now, so it should be always total mass over total volume. So let's look at this type of question in this one. It says a volume of 1.5 meter cube of water is mixed with this alcohol, right? And the density of this and this, the volume of mixture is 2. What is the density of the mixture? All right, is it clear? Now, if you notice, they haven't given us the mass, right? So most of the people, like if you do like 800 and then you take like 1000, it is going to be 1800, right? And then divide by 2, so it's going to give you 950, which is this answer, right? I think it's going to give you 900, no? I think it should give you, which is absolutely wrong. Now what you should do is, first of all, you have to find the mass. Now density is mass over volume. So for the first mixture, what we're going to do is, so mass 1 will be, density is like 1000 and the volume is 1.5. So I think it should be 1500, yeah, 1500 kilograms, right? Well, that's a lot, right? That's a lot. Okay, whatever. And then for the second one, it's going to be density over mass over volume, and the second mass is going to be density, which is 800 times 0.5, which I think will be 400 kilograms, right? Now the total mass over total volume will basically give us the right answer. So total mass was 1500 plus 400, about 1900 divided by 2. What's that? 950, right?
950.
Sorry, our answer should be 950, but according to this, our answer would have this. So obviously you would get a wrong answer if you do that. Do you understand now? So again, I'm telling you, do not attempt this method. It is absolutely wrong method, and lot of people do that. So do not get trapped into this. Anyway, surprisingly, I found the next question to be somewhat similar, and this would be your homework. This is just to practice. You look at the solution at the top, and then you just need to do the next one like this. All right, you will get it. So it's pretty similar. Now, if you've done this, please let me know. I want to go forward now. Okay. All right. So, yeah. Maham and Sultanate, Suhail, Umar, Wajia, Yaya, Javeria, Dark Legend, Laiba, Khatija Squares, Ayan, Aman. Everybody understands this?
Yes, sir.
Okay.
Yes, sir.
So then I'm gonna go towards atmospheric pressure and total pressure. Now, the breakdown of this chapter, I'm just gonna write a small breakdown, right? The breakdown is that you will have 10% questions from density only, all right? Like combined density and stuff like that, and normal pressure and stuff. About 50% questions are going to be for upthrust related questions, so you should be really focused on this one. And then about 20% questions are going to be mixed with the energy, okay, that we're going to do in the next chapter. And the 20% rest questions are from atmospheric pressure and difference in pressure. All right, so this is the breakdown of the whole chapter. But the main focus is that these two parts and that should be like completely flawless. So we're going to look at this and then try to make a maximum out of it. So first of all, we're going to look at the mercury. So basically a barometer, this is a barometer. I did not write it, I'm sorry. Barometer has vacuum in it. Wait a second. Hello. Malik Saab. जी 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 आप मुझे एक व्हाट्सएप मैसेज ड्रॉप करते हैं देन आई कुड जी ओके थैंक यू so what I'm basically saying is that here's the vacuum, and then obviously the pressure from the atmosphere is going to basically push this liquid, the mercury, top, and then it will have a column height. The column height, if you can see, is always taken from the top of liquid here to the top of liquid here. So that's the column height, right? And then simply you can use pressure equals to rho GH, and obviously the density is 13,600 times G is 9.81, and the height would be, you have to convert it into meters, which is 0.76. And could you please do this? Well, I think it should be this one, but can you please still confirm? So this is going to be like, this pressure has a name. It is called 1 atmospheric pressure, and this is a standard pressure at sea level, right? So sea level across the world is the same, you just need to remember that, and this level basically would not change, and that's the highest pressure that an atmosphere can basically act on the world. So you just need to remember that. Anyway, so going to a question where they've given you something like this, and they say a vertical tube is closed at one end and immersed in water, and the column failure is trapped inside the tube. The density of water. What is the difference between the pressure of air in the tube and atmospheric pressure? All right, so we just need to do that. So if you notice, the air would exert a pressure downwards, and the tube is trying to, you know, it's doing something like that. The real thing is that in this one, density is given, and obviously you should remember that this is the level where, like, the depth of the liquid, like, it is here, and the air is right till this depth, right? So we can find the two depths and the pressures. So pressure of air right now, it is somewhat here, so it's sort of balancing out. So we're gonna find it using rho gh. The density is 1000 of the liquid. It is 9.81, and the depth is from the top, which is basically 20 plus 30, and I believe that's gonna be 50. So that's gonna be 0.50. Could you please find the answer?
Four nine zero five.
79 4905 pascals, and then you have, like, here till here, you will see that that's the depth of water that's trying to balance it out. So which means that we're gonna say that pressure of water at that depth is going to be somewhat like what you get, wait a second, 1000 times 9.81, and the depth is sort of 30 30 60 60 20 0.80. Could you please answer that?
So 7848.
7848.
7
I think we take 0.80.
sorry,
We take 0.80.
we are finding pressure at this point, that's why. Do you understand that? All right, now what you get, sorry, come again.
7848.
Okay, I'm just trying to see where the difference is now. So right now, the thing is that we got this answer and we got this answer, right? Now, I just want to tell you something very, very important, okay? And the point that I want to make here, which is kind of, agreeable at this point, is that the balance is being, the balance is right here, which means the water is going to push it here and air is pushing it down. So basically they're like at this particular level, they have created a balance. Do you guys understand this?
Yes.
Now, what I want to tell you is that at this depth, wherever two liquids will ever meet, when two liquids or fluids meet, they have the same pressure at that point, right? Because this is the same point that we're looking at, which makes it that air could have been pushed, the air is being pushed up and the balance is here. That is why I would like to choose this answer over that answer, because the air has, the main difference is that the water is trying to push the air upwards according to only this much height. Do you guys understand? Above that there is just atmosphere. So the difference is that there is atmospheric pressure on top and then there is like water pressure, which is right here. So the difference between these two would be the air that is inside. All right, do you guys understand this, or should I explain it again?
Sir, explain again.
Okay, again. So what I'm saying is, in this question, let's do it again. So imagine this, right? At the top of the surface, at right here, at this position where the water surface is, do you guys agree that there is going to be atmospheric pressure?
Yes, sir.
So if I want to find the air pressure right here, right? Air pressure. So I know that's going to be pressure 1000 density times 9.81 and times the depth, which is 0.50. You agree?
Yes.
Yes.
So that is 4910,
Sir, why is it at 0.5?
because you have to take the depth from the top. Yes, sorry?
Why do you take 0.5 and not 0.3?
Because we have to take the depth always from the top. Like in this one, if I say you have to find the pressure, we have to find it from the top till the base we're looking at. So this pressure that we found is this pressure, right? So it is from the top till the base. Do you understand? So similarly, if I want to find the pressure here, I have to come from the top till this point. You get it?
Yes, sir.
Okay. Now think about it. Now think about it, please. So it's saying, right now, can we say the pressure of air that we have found is due to the pressure of water, which is above it, and plus the pressure of atmosphere, which is also above it. Do you understand?
Yes.
Now, what do they need? They need the difference between pressure of air and the pressure of atmospheric pressure. So pressure of air minus pressure of atmosphere would be actually this depth of water, which is 4910 atm. Do you understand now? That is why I chose this answer. All right. Any questions, please, now? Okay. Thank God. All right. So this was a tough cookie.
Sir, what is the atmospheric pressure then?
Sorry, come again?
What was the atmospheric pressure there?
We don't care what it was. We just need to find the pressure of air minus the pressure of atmosphere. Do you understand, Swell? And at that point, I just wrote that you should remember, at this point, if there is a point where two liquids or fluids are going to meet, it means the pressure of water and pressure of air at this point are equal. Like sort of, they are giving the same value. That is why I found the pressure of water at this point, and then the air pressure minus this, according to this equation, would give me the pressure of water at this level, and that is the answer. Do you understand now?
Yes.
Okay. Now keep this level in your mind, and it will, help you again in the next sort of question. So, for example, if a manometer comes, the manometer basically gives you the difference. What is this? Please charge. That's not fair. Okay, now it's on. So it's basically difference of pressure. Now let's do this. The first thing you will always do is you will find the point where two liquids or fluids meet. All right. So in this question, that point that we found in the previous question as well is this particular point. Do you guys agree?
Yes.
Which means I'm going to use this section and I'm going to cut it from here. When you cut it, you would realize that this whole liquid has the same pressure as this much of liquid. So at this level, both ends have same pressure. Do you guys understand this? Now, because if something is open from one end, you say this is atmospheric pressure, this is atmospheric pressure, right? So right now we're going to make equation on the left and the right. So on the left equals to right at the point we have to cut the whole thing, and here you have atmospheric pressure plus the pressure due to P equals to the right side atmospheric pressure plus the pressure due to Q. Understood?
Yes.
Right here, so you're only looking at where you cut it. Now, so atmosphere and pressure or atmosphere are both on the same side. We're going to cancel it out. So this will be density of P times G times the height of this is from the top till this point, which is 2x. And the other side, density of Q times G times the height is just x.
So why 2x is not going to be x?
Why? Because P starts from here and it ends here, so it is 2x, Ayan. So you always look at from the top. That's what I'm trying to explain to you. All right? And Q starts from here, ends here, so it is just x. So I wrote x. So G and G is going to cancel out. What do we need? Density of P over density of Q. So density of P over density of Q will be equal to x over 2x. That is just half, which means the answer is A. Do you guys understand now?
Yes.
So the idea is that
Yes.
you find that sweet spot where both the liquids meet, and obviously instantly your question is going to be solved, and that's not too hard. So I'm gonna go to, I believe, the next one, but you can copy this. It's all right. Just like we did it in the previous question, this is absolutely the same. So always look at this. Anyway, now going to the next part. Now in this question, it says that a U-tube is closed at one end, contains mercury, air, and the pressure is this one. So air has a pressure, so obviously pressure acts downwards. It's going to be this value. So this is pressure of air. And then it says fitted with a piston of 5 kg and blah blah blah, and density of mercury is given. Now, where do you think should I cut the tube from?
Where you started at?
Yes, where it is this point, because exactly at this point we are gonna get the same pressure. So you're gonna cut it from here, and now you will see that you need to include this one, which is the mass, and then obviously the atmospheric pressure because it's open from this side, and then this much of the mercury column. Do you guys understand this? Now what you're going to do is you're going to make an equation. So on that side you have atmospheric pressure plus the pressure due to the mass equals to, on the other side, on the right side, you have pressure of air plus the pressure of mercury. Do you guys agree? Now what you're going to do is you're going to put the values into it, okay? So Atmospheric pressure is this one, 1.01 times 10 raised to 5. Because there was no, if this was open on that side, we would cancel it out. Now, right now, there's like on different pressures on each side, so we got to do that. If you see, it has a mass and it has an area. Because pressure is given by force over area, so it means mass into 9.81 will be the force, which is the weight, and the area will be 5.0 times 10 raised to minus 4. So I'm going to add this here, just where it belongs. Air pressure is given as 5.0 times 10 raised to 4, and we need to find the rho gh. So density of mercury is 13,600, the g is 9.81, and the height of the mercury is h. Now we got to solve this. Can you please help me solve this? Find h. So it's a very, it's a technique where you can never ever get your answer wrong if you just find that sweet spot where two sides are meeting, and that's when you will be able to solve this question. Otherwise, I'm afraid you won't be.
So it's giving 1.11 centimeter.
So it's going to be 1.1
Sorry, 1.11
meter, right?
meters.
So this would be 110 centimeter. So it is that easy. Do you understand now?
So it doesn't matter if one side is like thicker than the other.
Doesn't matter, because you remember when we were like doing this, we were writing about pressure, and I said pressure is something that only depends on why did I remember I wrote it somewhere. Yes, pressure only depends on density, gravitational field strength, depth. It doesn't depend on shape, size, and color. And this is why they're trying to confuse you here. So whatever the shape is, do not worry, my friends. It has no added value to the pressure. It is just a gimmick to confuse you. Is it clear?
Okay.
Yeah.
Yes, sir.
Now, this question is absolutely superb, and I just want to tell you that obviously this is your homework, but before you go there, I would like to tell you which is the point that I should cut it from. All right, let me write a couple of points. 1, 2, 3. Which line should I cut it from?
3.
So 1.
3.
Okay, if I cut it from 1, what it would give me? There's nothing on this side, just atmospheric pressure. You would always want to cut it from 3. Why you would want to cut it from 3? Because this is the point where two fluids are meeting. Is it clear, Ayan?
So it's not me.
Okay, who was that then? Okay. All right. Who was it? So I can ask you if you understand this.
Yes, sir, I understand.
Okay. Which means now this side and this much on that other side, they have equal pressure. So right now you can put the left side equals to right side. Will you be able to solve this?
Yes.
Do you know what will be the height of the water on the right? Can anybody please tell me that?
30 minus
30
6.
minus L.
Exactly. So you're going to take it from this point to this point, which is 30 minus x. Now you guys already are, your heads are working. Congratulations. And now you can obviously solve it on your own. That's why this is your homework. And then the same thing you guys got to do.
Yes, sir, I have a question.
Yes, please.
Why would it be that the pressure is equal to the water on the right side rather than the pressure of the oil is equal to the water, pressure of the air and the water on the right side?
It is the same thing. Like here, on the right side, on the left side, it will be atmospheric pressure plus pressure of oil, and on the left side is going to be pressure of water plus pressure of atmosphere. So you add all layers like that. Do you understand?
Okay, sir.
Yeah, it is the same.
And so what is the point of the cross-sectional area?
No point. They just want to confuse you. This is a gimmick, like I told you. Do you understand? It doesn't really matter. Pressure only depends on density, G, and the depth. It has nothing to do with area or volume, or sorry, the shape, color, maybe any fitness, probably. Doesn't matter. Is it clear?
Yes.
Yeah. So please do not worry about that. This is like they just keep you, confused. So they keep on thinking, oh, maybe the area is more, so I should, add some part of it. It's not like that at all. Okay, so this one is the same. You have atmospheric on the, like pressure. There's water on one side, and then the atmospheric on top, and then you have this. So you have to cut it from where I can clearly see now. Your heads are working. It should be from here, and then you also have to do this. It is the same question again and again. They're gonna ask you. So do not worry about it. All right, at all. Anyway, so the last thing we're going to do today, and this is when we're going to finish the whole chapter. So forces in hydraulic systems are pretty easy. There's only one formula that you should be aware of. Basically, pressure is force over area, right? So when you apply a force over a certain area, so we can write it as F1 over A1. So what happens is this is pushed down, and because of this, the whole system, which has some kind of oil or incompressible liquid, this basically generates this pressure on the holes in the whole system. And then what this does is that this pressure causes this piston to move up. So the same pressure is for F2 over A2. So then you can combine these two formulas, and the formula you should remember is F1 over A1 equals to F2 over A2. Probably most of you have already done this in your IGs as well. So this is your prime formula that you should remember. In any case, we're going to move forward and we're going to check out this question, which is fairly difficult looking, but it's not. So it says the pipes are filled with incompressible liquid when a force is applied to the brake pedal right here. The pressure in the liquid increases and applies a force on 4 wheels. The area of piston connected to pedal is this, and the area of each piston to brake is this, right? And if the force of this is applied, like this is 800, so what will be the force? So we're just going to use F1 over A1 equals to F2 over A2. The force 1 was 800 applied on area of 8. The force 2 we need to find applied on 12. So what you get? I think 1200. I think. So that should be the answer. It is that simple. Is it clear?
Won't we divide? Why don't we divide it by 4?
Yes, interesting. Why don't we divide it by 4? Because when the pressure is generated in this whole system, so same pressure is for this one, same pressure is for this one, same pressure is for this one. Pressure is not being divided. It is the same for every piston. Do you understand what I'm saying? So which means every piston with a similar area would feel the same force. Understood?
Yes.
Yeah. The pressure is not divided. It's the same across every section of the whole system. All right. Anything else you would like to ask? Okay,
No, sir.
thankfully we are done with this chapter, and I hope you guys have some understanding now what you do. So I'm just creating the assignment here, and I believe you guys should be able to do it by, let's say, pressure, right? What was it? Force, density, and pressure. By the way, I might have to increase the number of, like, not the number of classes, just the duration. Like, we would start at the same time, but probably we're going to end half hour later than this. So which means, according to Pakistan time, it would be like, if we start at 5 p.m., we're going to end at 6:30 from the first week of March. I just want to make sure that we finish the syllabus within the time, and then start the past papers. Okay, so you submit it. These have a lot of drawings, so what I'm going to do is I'm also going to give you this PDF as well, like what I've solved, and those who might want to copy it later, but make sure do not submit my PDF, submit your own handwriting. That is very important.
Sir,
Yes.
the topical past papers, I think you didn't upload them yet. It was not working there.
I think it's working now. They're uploaded.
No, it's
They're still not
only
uploaded?
three, I think, three past paper is there. There's no topical past paper in that file.
Yesterday I checked, there was. Can you check again and tell me? 42 to 68. You can refresh because yesterday they were there. They were uploaded. 68. Okay. So I'm gonna put it in the classroom, and obviously IGAS. Okay. So this would be force. Okay. All right. So I'm gonna see you guys in the next class. Then have a nice day. Bye.
Without, sure.
Good afternoon.